This is part 2 on our discussion about intermolecular forces. I have discussed already ion-ion force, dipole-dipole force, and hydrogen bonding. Ion-ion force is the intermolecular force between ions, dipole-dipole force between polar molecules, and hydrogen bonding, a special type of dipole-dipole force in which hydrogen is attached to either fluorine, oxygen, or nitrogen. Let's discuss more types of intermolecular forces on this video. Let's start with the intermolecular force between the sodium ions and H2O molecules. So this one is obviously an ion. Again, pag merong charged particles or ions. So this sodium here is an ion. H2O, this one is a polar molecule. We already have discussed how this becomes polar. So again, sodium, it has a formal charge of +1. Then this one is a polar molecule. So of course, it's based on its electronegativity and the shape of the H2O molecule. So here we have isang oxygen, then dalawang hydrogens. Its shape is bent. Then for oxygen, this one is the electronegativity for this is 3.5. Then for hydrogen, 2.1. Again, 3.5 for the oxygens, then 2.1 for this one. Okay, so here it becomes partially negative, then this side becomes partially positive. Now, is there any point of attraction between this sodium ion, then we have this H2O molecule over here? There is, right? Here we have positive and this side is partially negative. So merong point of attraction over here. We call this force, this attractive force between these particles, we call this one as an ion dipole force. So this force is between an ion and a dipole. Again, dipole, this is referring to the polar molecule on this example. So again, this one is an ion dipole force. Let's proceed to Cl2. So let's consider the molecules of Cl2. This one is obviously a nonpolar because it's the same atoms bonded to each other. Obviously, they will have the same electronegativity. The electronegativity for Cl is 3.0. So this is 3.0 and this is also 3.0. Again, nonpolar. So walang formation ng partial charges, right? But based on our observation, so this Cl2 can also be attracted to other Cl2 molecules. But what is the source of attraction between these particles? Because again, there are no charge here because again, this is nonpolar. If you look into the complete picture, of course, merong electrons around this molecule. And again, these molecules, these electrons are constantly moving around this molecule. On sometimes they are here, on sometimes they are over here. Let's say at a particular moment, most of the electrons are on this side. So most of them are on this side. What do you think will happen to this side? So this side will become partially negative, right? Partially negative. And since, again, less ang electrons on this side because most of them are over here, this side will become partially positive. So here we have a dipole. Okay, so merong formation ng dipole, but this dipole is just temporary. So we call this one as a temporary dipole. Again, it's temporary because, again, these electrons are constantly moving around this molecule. So these partial charges can be formed at an instant and can disappear also at an instant. We also call this one as an instantaneous dipole. Instantaneous dipole because again these are formed at an instant. Again, instantaneous dipole. Now if you look here, this side is partially negative. Now this also, again, it has also its electrons on this molecule over here. So of course these electrons are negative, and again this side is negative, and again negative and negative, will they attract or repel? Again, same charge, they will repel each other. So since again this is negative and this is negative over here, so this one will actually, these electrons on this side will be pushed to this side because again they are repelling away from each other. So again, this is negative and it's also negative over here because of the electrons. This will be pushed to this side, so this will be repelled away to go to this side. So most of the electrons now are on this side. So this side will become partially negative, while this side, again, it has less electrons because they are repelled and pushed to this side. So this side will become partially positive. This side will become partially positive. Partially positive. Okay, so we also have now a dipole. Again, we have a separation of charge. We have two sides. But this dipole, this is caused by this one, right? So this is formed by the charge coming from this one over here. We call this one as an induced dipole, induced, okay? So this dipole is induced by this one. The word induced means caused by the other. Caused by the other, okay? Caused by the other. So if you look here, meron ng point of attraction because this is partially negative and this is partially, again, partially negative and the other side is partially positive. So merong point of attraction. This intermolecular force, we call this one as a dispersion force because again, it is because of the dispersion of the electrons around these molecules over here. Again, dispersion force. This is the weakest type of intermolecular force, and this force is found sa lahat ng this this is present sa lahat ng interaction. So this dispersion force can also be found on this one. It can also be found on these examples over here. So again, dispersion force is present sa lahat ng interactions between particles. Again, it's also the weakest type of intermolecular force. Let's proceed to some other types of intermolecular forces that have H2O then O2. So let's check this one. This one is a polar molecule and O2 is a nonpolar. Okay, here we have H2O. Again, it's something like this one. We have oxygen. Then this one is hydrogen. This is also hydrogen. Oxygen 3.5, 2.1 yung hydrogens. Then partially negative, partially positive, partially positive. Okay. Then here we have an oxygen or O2. Again, this one is a nonpolar. Again, 3.0, 3.0. Okay, so if we look again over here, by the way, this one is partially negative and the same thing right here. So there are also electrons over here. And again, these electrons are negative. So again, pag negative and negative, they repel each other. So these electrons over here, they are pushed, okay? They are repelled and pushed onto this side. Again, because of this charge over here, these are electrons. So magrepel. So they will be pushed to this side. So most of the electrons will stay over here. This side will become partially negative and this side will become partially positive. Okay. Now here we have a formation of a dipole and the same thing. This one is an induced dipole. Again, induced dipole. So this dipole is caused by this particle over here. And again, the same thing. Partially positive, partially negative. So merong point of attraction. Okay. So this force, we call this one as a dipole. Dipole, that's the polar one. Then, of course, ang non-polar, this becomes a dipole. So that's an induced dipole. Dipole, induced dipole force. Okay, that's another type of intermolecular force. Again, this dipole, this is referring to the polar. Then ang kanang induced dipole, this is referring to the non-polar that has become dipole. So it's an induced dipole. Let's proceed to another one. We have Mg plus 2 and O2. So this one is an ion, right? Again, pag merong charge, this one is an ion. Then O2, this one is a nonpolar molecule, nonpolar. Again, Mg2 plus, so this one is an ion na merong positive charge. Then here we have oxygen. This one is a nonpolar one. Again, merong electrons over here. Again, electrons are negative. So here we have a positive side. This particle is positive. So of course, positive and negative. Of course, again, positive and then negative, they will be attracted to each other, right? Attracted to each other. So these electrons over here, they will be attracted to go on this side. So again, on this case, these electrons will move on this side. So most of the electrons will stay over this side. This will become partially negative. And this side, since less ang electrons, because again, most of them are moving over here, this side will become partially positive. Okay, so this has now become a dipole, and the same thing, this dipole is caused by this one. So this one is also an induced dipole. Induced dipole. Okay, so this is partially negative, this is positive over here. So merong point of attraction. So over here, we call this force, this attractive force, as ion. Ion, then the other one is induced dipole. So we call this one as an ion induced dipole force. Induced dipole force.